Hello, so today we are going to do problems from this week's weekly contest 319. And the second problem is apply operations to make sum of array greater than or equal to k. So we have a positive integer k, and we have an array where initially the array is at just value 1. And you can do any of two operations. You can do them any number of times, including 0. Basically, choose any element of the array you have so far and increment it by 1. Or the other possible operations is you can duplicate the element and add it to the end of the array. So I'll say there was 4, you could add another 4 to the end, okay? But the goal is how many of either of these operations or combination can you do to get the sum of all the element in the array to be greater than or equal to k. And what we're looking for is the minimum number of operations. So just the minimum number of operations we can make. So basically, you can think of it as how quickly can we get the sum of the array to be greater or equal to k. Okay. So for example, with 11, what we can do is we can keep increasing so start with 1 in the array. We can keep increasing it until we get to 4. Then do the second operation 3 times. And that way we get 12. With 1, we don't need to do anything. It already has sum of 1, so we return 0. Okay. Now, k can be up to 10 to the power of 5. So pretty big. But if you take a look here, this actually gives you a clue. You can see we kept increasing, and then at some point we just doubled. Why? That's the key inside of the problem. But why? Because if you, let's say, there is some point, right, where incrementing will just add more operations, because incrementing just, if you can, like, if you are at 4, is it better to have 5 in the array and then have 5 afterwards? This is 3 operations, right? This is 3 operations. Or is it better to have just 4 3 times? Okay. So 4 3 times, this is 12. For us here, it's better than 11. This one is 10 plus 4 is 14, bigger than 11, but still this is already bigger than 11. Okay. Now what about, let's say, if we do with just 2? With just 2, the problem is that this doesn't get us to 12. This is just 6. With 3 operations, with 2, this is just 6. Okay, so we may as well do 2 operations to increment, so 3 and then to 4 and then add 4 3 times. So this is overall 5 operations. But let's say we add 5 operations like this. So here we do 5 operations, we do 5 operations here. So if we do 5 operations here, 6, 8, 10. So this gets us to 10. But this 1, 2, so how many we have? We have 3 4s, which is 12, which gets us to 11. So what I'm trying to say is that with the same number of operation, there is some point where it doesn't make sense to increment. We can get to greater than or equal to k with less operation. But once we get to that point, the 4 here, it doesn't make sense to increment, because right, we will get to k, greater than or equal to k, but we already can get to greater than or equal to k with that number, right? And so that's the key insight here, okay? And so what we are looking for is just find that number, let's call it x, where we should only increase, okay? And it's hard to find it, right? Because there is no real way to find it. There is no like real heuristics, so we may as well try everything. We know that this x has to be in the range 1 to k, right? Because we only want to reach k. If we have x equal to k, we know already we reached k, right, with the sum. So we only need to look in this range. And we can just find the minimum number of operations that will get us to a sum. So we can just go through this, and we can just do the minimum number. So we calculate the number of operations for x and just check if this is the best or not, right? So just take min of the best so far and the minimum operations with x. What does x represent? X basically represents that we we will keep incrementing. So x here represents keep incrementing until we reach x. Then from there, duplicate. That's what all this means. Okay? And so we just return that best value. Okay? So the crux of the idea here is that there is some value between 1 and k where once we reach it, we are always better off just doubling, just duplicating, doing the second operation instead of doing the first one. Okay, and we just need to find the minimum number of operation for which number that gives us the minimum number of operation. In this specific case, that number is 4. But for some other case, it may be different number, but it sure can't be more than k, because if it's more than k, then we'll reach it in the first iteration, right? So we can just take some in the first iteration, but we'll have to do +1 multiple times. And so we just need to look for the best number here. So how do we do that? So we can just do like this for x in the range of 1 to k. And so we need to do some incrementing operations. Let's call them increment operations. How many? We just need to do until we get to x. But remember, we already have initially 1 in the array. So we only need x minus 1. Okay? And now how many numbers we need for the duplication? Well, think of it as we want to reach k, at least k, because it's greater or equal to k. And so, and we know we reached x. From x we'll duplicate. So how many times we duplicate? Well, we duplicate, let's say we want to reach 12, and we need to duplicate 4. How many times we need to duplicate 4? Well, we needed to duplicate 4 3 times, 12 divided by 4, right? And so we just do k divided by x. But the problem is, what if the number is, like in this case, the number k is 11, right? And so 11, if you do 11 divided by 4, that's 2.75, which is like 75 here. That's not what we want. We want 3, which is the ceiling. Because remember, we want greater or equal to k. So less than k, that hurts us. That doesn't work. But bigger or equal to bigger is fine. And so let's just do the ceiling to get to the bigger number. And so that's what we do here, math.ceil. Okay, so, but the other thing is we already have a 4 from incrementing, right? So think of it as we need 3 4s to get to this, right? We need 3 4s, but we already have 1 4 from incrementing. We just need to add 2 more. So how many we need to add? We just need to add 2 more, because there is already 1 over in the array. And so that's why we do -1 here, because we already have 1. And so this is the operations for duplicate. And the total number of operations is just first increasing and then duplicating. And we can also just make this super clear. We need to initialize best. Now, what's the worst case scenario? Worst case scenario is we need to increment, just keep incrementing until we reach k. And for that, we just need k minus 1, because we already have 1 in the array. And if best is smaller than the number of operations we need here, which is just inc plus duplicate operations, if it's smaller, then we can just assign it. Okay? And then we can just return best. Okay, let's see. Looks like there is maybe a slight problem here. So if the number of operation is smaller than best, remember we are looking for the minimum. So this should work. Looks like it's good. We can submit, and it passes. Okay. So that's the greedy approach we can solve this with. In terms of time complexity, this is O of k. We should pass given the constraint we have, and no extra space really. And yeah, so that's pretty much it for this problem. Thanks for watching, and see you on the next one. Bye.